Welcome you all. Today we are going to discuss a topic called Huffman coding by performing a greedy technique from the subject of design and analysis of algorithm. So moving on to what is a greedy technique? What is the types of coding we have? We have two types of encoding. One is fixed length encoding. Another one is variable length encoding. What is fixed length encoding? Each code will be having the same length, whereas variable length encoding will be having a different length. So say for example, they have given S is equal to A, B, C, D, F. The frequency they have given for each and everything, we have a same length. See here all having the 3 bits, 3 bits, 3 bits. Whereas here for the ABC we have different kinds of length. That is what variable encoding. So moving on to the Huffman codes. What is Huffman codes? It is a lossless data algorithm. So it uses variable length encoding and it is most frequently occurring character will be having the minimum code length and the least frequently occurring character will be having the maximum code length. So to prevent ambiguity in decoding, it will be using the prefix free codes. So this Huffman coding consists of two parts. One is building an Huffman coding tree from an input characters. Another one is traversing the Huffman tree and assigning codes to the characters. So what are the steps that has been involved in constructing the Huffman coding trees? Initialize n nodes, one node trees, label them with symbol of alphabets, record the frequency of each symbol in its tree to indicate the tree weight, and identify two trees with the smallest weight, make them as the left and right subtree of a new tree and with their roots as the sum of their frequencies. And repeat the steps above until a single tree is obtained. So the tree whatever we obtained is called as Huffman coding tree. So we will see a problem. We have taken an example of ABCD hyphen. So they have given the frequency. If not given, you have to calculate the frequency based on the number of occurrences by total number of occurrences. So they have given us 0.35, 0.1, 0.2, 0.2, 0.15. So we are going to construct an Huffman coding tree. So first we have to arrange the alphabets or the given characters in an ascending order. So I have arranged it in an ascending order. Now I have to find out the least two frequencies and I have to make it as one as left subtree, another one as right subtree, and I have to add it together and the root will be the sum of the frequencies. Okay. So I have to choose the minimum, which is minimum 0.1 and 0.15. So I am forming a new subtree. See here 0.1 plus 0.15 is 0.25. So B becomes left and hyphen becomes right. So I have founded a new subtree. So this is my new subtree. I have added these. Remaining I have these three things. So now I have to arrange this new subtree. I have to insert this new subtree along with the existing nodes. So I am going to arrange it again in increasing order. See here, after arranging it, I am finding out here. Again, repeat the procedure. Find out the least two frequencies, that is C and D. So add these two frequencies. Then form a new subtree. So 0.2 plus 0.2 is 0.4. So it's a C and D. So C becomes left and D becomes right. Again, I have been left out with this one and a new subtree. Again I have to rearrange it in the increasing order. So I will be having increasing order. This is my increasing order. The least two subtrees, this is the one. I have to add these two and form a new tree. Choosing the two minimum, form a new tree. So 0.35 plus 0.25 is 0.6. So I have found it out. So now again I have to arrange it in an increasing order. So arranging it in an increasing order, forming a new subtree. 0.4 plus 0.6 is 0.1, sorry 1.0. So this is my new subtree. So finally I have founded a single tree. This is called Huffman tree. So left branch I am going to assign 0 and right branch everything I am going to assign it as 1. So after assigning it, so I have to traverse it and find out the code. For C it is 0 0. So from root to the node. From D it is 0 1, see here, 0 2 1. For B it is 1 0 0, right? For A it is 1 1 and 6 it is 0 1. So 1 0 1. So see here, it's having different number of digits. So it is called variable length coding. So average code length is calculated using a frequency into code length by the number of frequencies. So 2 number of digits, 2 here, 3 here, 2, 2, 3. So into the frequencies. So 2 into 0.35, 3 into 0.1, 2 into 0.1, 0.2, 2 into 0.2 and 3 into 0.15 divided by all the total frequencies gives me the average code length, that is 2.25. So if you have a fixed length encoding, so it will be have 3 digits. So using an average length minus length in bits, it is 2.25. So see here, the rate has been tremendously reduced. The compression ratio that has been achieved using the Huffmann coding is fixed code length minus average code length. What we have achieved, that is 3 minus 2.25 divided by the fixed code length into 100. So 25% efficiency we have achieved. So this is what an Huffmann coding using a variable code length coding, we have achieved 25% efficiency. So hope you understand and find it useful. Thank you.